We're going to keep going through the different types of connective tissue that you need to be familiar with. So in the last little video clip, we talked about the first handful of connective tissue types: areolar, adipose, regular dense, and irregular dense. And those are made up of something called fibroblasts. That's the type of cell that forms those types of tissues. The next set of connective tissue, it's going to be a different type of cell, and that is going to be cartilage and bone. So cartilage you're probably familiar with, right? So cartilage is at the ends of your bones, but it also exists in some other parts of the body. And we're going to get into that now. So the first type of cartilage is called hyaline cartilage. And hyaline cartilage is the most common type of cartilage. You're going to find this at the ends of your bones. It's what makes up your nose. So like if you take your nose right now and feel your nose, the end of your nose, you can kind of move it back and forth. That is going to be hyaline cartilage. Another example is if you go to your throat right now, and this is going to feel kind of weird, but feel up and down your trachea. And what you'll feel is there's these little rings that are hard. So if you try to squeeze your trachea, you can't really squeeze it because there's those hard rings. That is also made up of this cartilage called hyaline cartilage. So let's talk a little bit about the components, and then I'll address the things that are on that table for you to fill in so you know what to write. So first off, this is not a fibroblast tissue. Fibroblasts are found in, like I said, regular dense tissue, adipose, areolar, but in your cartilage, it's a different type of cell. It's called a chondrocyte. And a chondrocyte is basically, it's a cell that differentiates from a stem cell, so you probably learned about that in biology a little bit, and they form into these things called chondrocytes. Now, chondrocytes do something very, very bizarre. So let's take a look at this image real quick. This is a picture of some cartilage that you would find like at the ends of your bones. It's also what makes up the skeleton of a developing embryo. So when you were first developing inside of the uterus, you didn't have a skeleton yet. All of your bones weren't formed yet. They were in the form of cartilage. And then that cartilage becomes bone over time. So let's take a look here and see what's happening. So what you'll see is you can see there's these pink rings. And those pink rings are something called a lacuna. Or if there's more than one, you call them lacunae. And we're going to talk about this for a moment. Now, you'll see there's a circle, right? That's the cell itself, and then there's a little purple dot in the middle. And that little purple dot is the nucleus. Now, one thing I want to point out to you is not every one of these little circles has a purple dot. And it's actually kind of a sad story. Here's what happens with your chondrocytes. These cells do something that is very weird in terms of cells. A cell, life wants to propagate life, right? If you're living, you want to keep living. No, organisms don't purposely, put themselves in a situation where they can't live. But cartilage does something very unique. It actually intentionally kills itself, right? It's kind of dark, but it's true. So the cells here that don't have a purple dot, those are actually dead. And what happens is these cells produce a matrix made up of very fine collagen. So if you're filling in your chart right now, the cell type is a chondrocyte. The matrix is made up of fine collagen, very, very fine collagen. It almost looks like glass, and that's what hyaline means, actually. It means glass. So when you look at it under a microscope, it kind of looks like glass here. But what happens is these cells build a wall around themselves. So imagine you're a cell, right? And you're producing collagen. And that collagen is coming out of your ears and your nose, like I said before, right? It's weird to think of it that way. But what they do is they actually pin themselves in. And they build essentially a little house around themselves. And that feels nice at first, probably. They have this nice little protective covering that protects them. But once that gets thick enough, what ends up happening is they suffocate, right? They can't get their oxygen anymore. Blood can't get in, and what ends up happening is they die. And when they die, they leave behind these little lacunae, and they're essentially little rooms. So here's a dark analogy, and I apologize, but let's say somebody lives in a house for a long time, and then they die. That house still exists, right? The house stays behind. And that's what you're seeing here. You're seeing these little lacunae, which are these circular walls that these cells build around themselves. So in this image here, everything with a purple dot in the middle is a living chondrocyte. It is a living cartilage cell. However, over time, those cells are going to suffocate and they're going to leave behind these empty rooms. And that is why your cartilage actually acts as a shock absorber. It's not living anymore. So at the ends of your bones, we have cartilage, and that prevents your bone from rubbing on itself. So when you move your bones, a meniscus is a great example. I know some people have meniscus issues probably in this class. If you're an athlete, you might have had a meniscus tear. A meniscus is made up of a similar substance. So your cartilage and at the ends of your bones, your nose, the rings in your trachea, those are all examples of what we call hyaline cartilage. The next type of cartilage is called fibrocartilage. Anytime you see fibro or fibrous, that means it's tough. So this is a tougher version of cartilage. And this is a very tough tissue made up of a tougher collagen. And so what are the cells? It's going to be chondrocytes again, because anything that's cartilage is going to be a chondrocyte. They also have lacunae. They do the same thing, but their collagen is it's not fine like in hyaline where it's a little more flexible. This fiber cartilage is much, much tougher. And these are going to make up the discs in between your vertebrae. So if you look at this image here, this shows you, this would be a spine, right? This is the spinal column, the vertebral column. And then in between each vertebrae, we have one of these little discs. That is called an intervertebral disc. And that is made out of fibrocartilage. So they're tough and they're there for shock absorption. So if I go back to the notes here, we have our example of our fibrocartilage. So that is going to be the shock absorbers between the vertebrae, and then at the base of your pubic girdle, which is where your pubic bone comes together, there's a little piece of cartilage there, and that allows for some flexibility of your pelvic girdle, which is your pelvis bone. And that is why in women that allows for pregnancy, right? There needs to be a little bit of give to that pelvic bone, so when a woman's carrying a baby, it can flex, and that is that fibrocartilage. So hyaline cartilage is going to be fine collagen, and that is there. It makes up the baby skeleton, or the embryo skeleton, I should say. It makes up the nose, the trachea, the ends of your bones for, protection of those bones. Fibrocartilage is much tougher collagen, and that is going to be found in those intravertebral discs and also the pubic girdle, which is where the pubic bone comes together. And then the third type of cartilage is called elastic cartilage. It is also made up of chondrocytes. So anything that says cartilage, the cell is going to be a chondrocyte. And if you take a look at this image here, you can see it looks pretty similar. You have your cell here. The nucleus is going to be what's labeled A, and then you have your lacunae, right? Those lacunae are those little rooms, those walls that the cells build around themselves. And then you can see here, the cells that are empty are dead. So it's the same exact idea as the hyaline cartilage and the fibrocartilage. The difference is elastic cartilage, instead of it producing a lot of collagen, it produces elastin. So what is going to be an example there? Your ears. So everybody feel your ears, flop your ears, and then feel your nose, right? Go like this, right? I look like a weirdo doing this, but it's for a purpose, right? So what you'll feel here is your nose is much tougher than your ears. That's because your nose cartilage is going to be hyaline cartilage, which has got more collagen, and your elastic cartilage allows for flexibility. Why are our ears flexible? Well, imagine if they were as hard as your nose. They would break off much easier. So the flexibility of our ears allows them to not rip or tear if you get hit in that ear. Also, it's what is found in our larynx. It's in our voice box that allows for the flexibility. So it provides flexible support. So in terms of your chart, your elastic cartilage is going to be made up of chondrocytes. So the cell is going to be a chondrocyte. And then we have our matrix is going to be mostly elastin, and it's going to have those lacunae like we said before, and the function here is flexible support. We're going to keep moving. Okay, the next type of connective tissue is very unique, and it is blood. Okay, blood you would not think of as being a tissue like bone and like cartilage, but blood is technically a tissue because it is cells found in a matrix. So let's write down the cells. The cells that are found are going to be platelets. So if you take a look at this image here, you can see there's three types of cells here. These are going to be your red blood cells. This is a white blood cell here. That's actually, I can tell that's a lymphocyte based on the size of the nucleus. And then these little dots are platelets. So blood is made up of three types of cells. The platelets are going to be found in there. And also there's going to be red blood cells, which are used to transport oxygen, and white blood cells, which are used for immunity. So under cells for blood, it's going to be red blood cells are going to be for transport of gases, white blood cells are going to be for immunity, and then platelets are going to be for blood clotting and protection. What is the matrix? It's a liquid matrix, which is called plasma. So the matrix is going to be plasma. What is the function of your blood? Well, I just told you. Red blood cells are for oxygen and carbon dioxide transport. White blood cells make up your immune system. And platelets are there for blood clotting and protection. We're going to finish up here with the last couple. Elastic connective is often confused with elastic cartilage. They are not the same thing. Elastic cartilage has chondrocytes. Elastic connective, we're back to fibroblasts again. So elastic connective tissue is going to be fibroblasts. And they are going to be found between the attachments between vertebrae. This is very flexible. So the matrix is going to be elastic fibers. This is like tape. It's so flexible. It allows for tons of flexibility. So just to make sure we know the difference here, I'm going to bring up my image here. So if you take a look at this diagram, this is a intervertebral disc which is made of fibrocartilage. So that's fibrocartilage. Now, our spinal column is able to flex, right? You can move back and forth. So everybody do this in your seat. Move back and forth, go up and down. And the reason we're able to do that is because along the sides of the vertebrae, there are pieces of elastic connective tissue which allows for that flexibility. So those are two different things. So the elastic connective tissue, so the elastic connective is going to be along the sides of the vertebrae. So it is not the same thing. And this is something that students get wrong all the time. They confuse, they hear vertebrae and they're just like fibrocartilage. And I get that, right? It's easy to mix it up. But the fibrocartilage is what makes up the discs in between. So that's fibrocartilage. And elastic connective, not elastic cartilage, elastic connective tissue is what makes up the very thin layer of connective tissue which keeps the vertebrae aligned in the spine. Okay, one more and then we're done. The last type of tissue is reticular connective, and we already talked about this. Reticular connective is going to be made up of fibroblasts, so that's the type of cell. It's going to be what makes up your organ's structure. So it makes up the walls of the liver and the spleen. We already talked about reticular connective. It's a mesh-like collagen network. So the type of matrix would be mostly fine mesh-like collagen. So it makes a mesh-like network of collagen, and it is used for support and to give structure to your organs. So reticular connective is going to be what gives structure to your organs. It's made up of collagen, fine collagen network of mesh, and it's made up of fibroblasts. We've got one more type of tissue which I'm going to cover very quickly, and that is bone. And bone is a lot like cartilage in the sense that it's hard and it's for protection, but the big difference is cartilage is made of chondrocytes, that's the cell. Bone has a different type of cell that are called osteocytes. Osteo means bone, so these are bone cells. What you're seeing in this image is that's an osteocyte there, that's an osteocyte there, and they're embedded in this matrix, which is what makes up the bone. So what is the matrix for bone? It is made up of collagen and elastin, but also it has mineral salts. Calcium specifically. So if I were to ask you what is your bone made of, you'd probably say calcium, and you'd be right. Calcium is a huge component, but there's also collagen and elastin, and bone is very special. It is hard, but it's also flexible. We're going to talk a lot about bone. That's the next unit, so I'm not going to spend time on it now. Another thing about bone that makes it unique is the fact that it does build this hard shell around itself, but it doesn't suffocate like chondrocytes do. It is still able to breathe because it makes these little tunnels, which I'll talk about later on. And then finally, what are the functions of it? It's used for support, muscle attachment, protection of your organs, and also formation of blood cells. So those are all examples of functions of this tissue. So for your chart, the type of bone is an osteocyte. The matrix is made up of collagen, elastin, and mineral salts like calcium, and the function or job are going to be support, muscle attachment, protection, and blood cell formation. And we'll go into much more detail on this in the next unit.